Hello, everyone. So for this lecture, we're going to look at the organs that go with our lymphatic system. We're also going to look at an overview of leukocytes, which are our immune cells. So last class, we looked at antigens and antibodies. Now we're going to look at how different organs are really used and what they do for our lymphatic/immune system. So the first one is the spleen. And if we look at this picture here, your spleen would be right there. It lies on the left side, kind of hugs around your stomach. And most importantly for the lymphatic system, it's what we call proliferation. Proliferation just means to increase the amount. So when you get sick, your immune cells, your leukocytes, have to kind of speed up. So this is one of the areas where leukocytes, specific B cells, and possibly some other cells will be mass produced. Okay, your spleen also has two other jobs. It breaks down worn out blood cells, especially red blood cells, and it's also a blood reservoir, meaning that when more white blood cells need to be sent somewhere, they're kind of just waiting in limbo, waiting to be sent out from the spleen. The second one is called our thymus. This is really important when we look at the T cells, and we'll get to B and T cells specifically towards the end of the chapter. But your T cells, they get their name T lymphocyte because they become immunocompetent in the thymus. Now, immunocompetent is a long word. What that means is they become very specific. And inside of your body, when you get sick at various times of the year, or hopefully not that often, or every year you might get sick in the winter, that's a new bacteria or a new virus getting into your system. So you need to produce new T cells. Your old ones protect you. You have memory of what you've been sick from in the past, but new ones that come in, they have to become, these T cells need to become immunocompetent, which means they need to become specific to that bacteria or virus that has gotten into your body. Now, it's more prominent early in your early ages, mostly because when you're younger, you're coming in contact with new stuff, right? All the bacteria that's in the world and the viruses, every time it comes into your system, it's new. So you're getting more T cells being made, and these memory cells, they have to be stored in your body. Now, as you get older, you come in contact with some of those same viruses and the same bacteria. So you're not making new T cells. You're going to use your memory cells, and they're just going to make these leukocytes or these T cells to then destroy them. So there's a difference between having it stored inside of our system already and then first coming in contact with it. And that's where this thymus really comes in. So as you become older, your thymus actually shrinks down because you've come in contact with so many germs, so much bacteria and viruses that you have it already stored inside of your system where you don't have to make new ones, really. Okay. You have tonsils. Some of you may not have them anymore. They used to remove these a lot more often, but doctors kind of realized that, hey, the tonsils are one of the first capturing sites of germs getting into our system as we breathe in. So more times than not, we're trying to hold on to these tonsils, or what we call adenoids as well. And we have a bunch of different tonsils in our mouth. You know the two that are kind of hanging around in the back of your throat, right around the uvula, but you also have some other ones that are in your nasal area right here, and you also have ones that are kind of back behind the tongue that we don't really talk about too much. Okay, but their job is to gather those pathogens as we breathe them in. We talked about Peyer's patches briefly in the digestive system. So as we go to absorb nutrients, we want to make sure that if there are bacteria that are harmful, we can actually destroy them. And if you look right here, here's a villi with microvilli being displayed right here. But what I want you to look at is right up the villi, and you'll see that you have arteries, you have veins, and then you also have that green line. That green line, they have it labeled as lacteal, but really that's the extension of the lymphatic system. So as you're absorbing stuff into your bloodstream, those bacteria will get into the lymphatic system, and those Peyer patches are going to destroy them before they can make their way really into our bloodstream. So our lymphatic system, like I said in the first lecture, your lymphatic system goes hand in hand with your arteries and veins, because anywhere there's going to be exchange happening, we want there to be your immune system ready to destroy it if there is bad bacteria or viruses. Okay, so those are the different organs that we really see, and I'm just going to briefly go over the different types of cells, or the leukocytes, or immune system cells, and we're gonna kind of work on a chart to try to make sense of this. This is a difficult chapter, but I'm going to make it as simple as possible. Okay, so if you look here, these are little antibodies going after the bacteria, like we talked about, and that's one of your immune responses, is actually tagging some of those bacteria so they can't work, or tagging a virus and then setting them up for destruction. So here's the overview. There's 5 different large cells, or classifications. They're not all large in size, but there's 5 classifications of leukocytes. Now remember, leukocytes is a fancy name for white blood cells. You have what are called neutrophils, which are very, very important. They are your fastest traveling leukocytes, or white blood cells. So if you get a cut, or let's say even if you have a bacteria that gets into the pores on your face and it becomes inflamed and you get a pimple, and then sometimes you get like a whitehead, those are actually neutrophils that have come to the site. They're looking to destroy whatever it is, and they usually swallow up whatever they can, and then they die right on the spot. Okay, they are the most abundant, as it says there. They are circulating your body all the time. So right now in your body, your neutrophils are just kind of floating around. If it sees a bad bacteria, it's going to go and swallow it. Okay, it uses phagocytosis, which means it swallows it up. Okay, but they usually die immediately once they swallow up their bacteria, and then they turn into this white form called pus. And that's kind of one of the things that we look for if there's a major infection. That means there's a lot of neutrophils going to that area, because there's a large amount of bacteria that's getting into that area and it might be infected. Okay, you have two other classifications here: eosinophils and basophils. They are mostly used in allergic responses. Eosinophils, anything that's an allergen causes a reaction. And people might say, like, well, then why do we have them? Because allergic reactions are terrible. It's the way our body is made. If it thinks that something is foreign, it needs to create a response to it. And one of those, sadly, is inflammation. So it calls in basophils to produce inflammation at a site. And if people eat the wrong thing that they're allergic to, it causes the throat to swell up. And that's due to the eosinophils recognizing that food or pollen, whatever it may be, it responds to it as an allergy or a foreign material, and then it triggers your basophils to really start releasing histamine, which is causing inflammation. That's why we talk about antihistamines, and that's supposed to bring down that inflammation. We see that with like Benadryl, the pill, or you can take it as a liquid. And that causes that inflammation hopefully go down, or that response, that allergic response, to go away. Okay, 2 others. One are your lymphocytes. Now, lymphocytes, we're talking about the lymphatic system. So those are found in our lymph nodes or in our lymphatic system. They do travel in the blood, but they do most of their work in the lymphatic system, hence why they're called lymphocytes. They're found in the lymphatic system, or in the lymph. And I'm not going to go through each of them, but you have what are called natural killer cells, which are one of the coolest cells in your body as to what they do. You also have T cells and B cells, and they are a bigger response to an infection. Okay, but we'll get to that. This is just classification. And then the 5th one is called a monocyte, and those become huge macrophages. And macrophages are big cell eaters. Now, they can consume multiple bacteria or fungi. They can engulf them and stay alive. They're not like the neutrophils. Neutrophils, they die immediately, but monocytes, which become macrophages, so they're big cell eaters, they can just keep gobbling things up over and over and over. And they're found in a lot of different areas in your body. They can be found in your skin. If you remember back to the integumentary system, we talked about Langerhans cells a little bit, and they're kind of in the surface, kind of close to the surface of your skin, and they will engulf anything that kind of gets in there immediately. Okay, so that's the classification, or your 5 major categories of leukocytes. You have your neutrophils, which are the fastest to get to an infection. They eat them up. They eat up those bacteria, and then they turn into a white substance, which we call pus. They are what we call a one and done. So they eat and they die. Eosinophils, they are acting at, or they are being triggered by an allergen, so something that our body doesn't recognize. And they cause a response such as basophils for inflammation. And we'll talk just a little bit about them in the future, but we really don't. We hit on the other ones more times than not. Okay. And then we have our lymphocytes, which we'll talk about: natural killer cells, T cells, and B cells in the upcoming lectures. And then you have your monocytes, which are everywhere in your body, and they are big eaters. They're going to eat up as much as we possibly can. They also respond to different triggers to kill those bacteria and viruses.